prepare for the Journeyman exam in the heating, ventilation, air conditioning, and refrigeration field, consider these resources and study tips. Firstly, several books are highly recommended. Modern Refrigeration and Air Conditioning by Andrew D. Althouse, Carl H. Turnquist, and Alfred F. Braxiano is a comprehensive resource. Secondly, Refrigeration and Air Conditioning Technology by John Tomczyk provides detailed explanations. Thirdly, Refrigeration and Air Conditioning Servicing by Steve Handy focuses on practical applications. Fourthly, the HVAC Systems Design Manual by Ashry covers design principles. Fifthly, Refrigeration, Air Conditioning, and Heat Pumps by William C. Whitman and Robert F. Wilson offers a thorough overview. These books offer a strong foundation in HVACR principles and practices. In addition to books, several websites can be valuable resources. HVAC Talk / is a popular online forum for HVACR professionals and technicians to discuss technical issues and share their knowledge. Engineers Edge / provides engineering tools, data, and resources, including HVACR-related information. Ashry / is the official website of the American Society of Heating, Refrigerating, and Air Conditioning Engineers, offering standards, research, and publications. The Refrigeration Engineers and Technicians Association (RETA) is a professional organization for refrigeration operators and technicians, offering training and certification programs. The Air Conditioning and Refrigeration Institute (ARI) provides industry standards and certification programs for HVAC equipment. These websites offer valuable information and resources for HVAC professionals. Here are some additional tips to help you prepare for the Journeyman exam. Firstly, review your old textbooks and notes. This can help you refresh your understanding of fundamental concepts and principles. Secondly, attend webinars or online classes. Many organizations and institutions offer online courses and webinars on HVAC topics, allowing you to learn from experts in the field. Thirdly, join discussion forums and ask questions. Engaging with other professionals and technicians can help you clarify your understanding and learn from their experiences. Fourthly, practice solving practice exam questions. This can help you familiarize yourself with the exam format and identify areas where you need to improve. Fifthly, focus on understanding the underlying principles rather than memorizing formulas. A strong understanding of the fundamentals will enable you to apply your knowledge to different situations and solve problems effectively. Sixthly, break down complex topics into smaller, more manageable chunks. This can make it easier to understand and retain the information. Seventhly, study consistently and don't procrastinate. Regular study sessions will help you stay on track and avoid cramming before the exam. Eighthly, consider hiring a tutor or joining a study group for support. A tutor can provide personalized instruction and guidance, while a study group can offer peer support and motivation. Specifically consider these additional technical details as you study. Understand the refrigeration cycle, including evaporation, compression, condensation, and expansion. Know the properties of different refrigerants and their applications. Be familiar with different types of compressors, such as reciprocating, rotary, and scroll compressors. Understand the operation and maintenance of air conditioning systems, including window units, split systems, and central air conditioning systems. Be familiar with different types of heating systems, such as furnaces, boilers, and heat pumps. Understand the principles of heat transfer, including conduction, convection, and radiation. Be familiar with different types of ductwork and their applications. Know how to calculate heating and cooling loads for buildings. Understand the principles of ventilation and air quality. Be familiar with different types of air filters and their applications. Understand the principles of psychrometrics and how to use a psychrometric chart. Be familiar with different types of control systems, such as thermostats and humidistats. Know how to troubleshoot and repair HVACR equipment. Understand the importance of safety in HVACR work. Be familiar with relevant codes and regulations, such as the National Electrical Code, NEC, and local building codes. Let's delve into more specific areas. You should understand electrical fundamentals, including voltage, current, resistance, and power. Be able to apply Ohm's law to calculate voltage, current, and resistance in electrical circuits. Know how to read electrical schematics and wiring diagrams. Be familiar with different types of electrical components such as resistors, capacitors, inductors, and transformers. Understand the operation and maintenance of electrical motors used in HVACR equipment. Be able to troubleshoot and repair electrical circuits in HVACR equipment. Understand control system fundamentals, including open-loop and closed-loop control systems. Be familiar with different types of control devices, such as thermostats, pressure switches, and flow switches. Know how to calibrate and adjust control systems. Be able to troubleshoot and repair control systems in HVACR equipment. For refrigeration, understand different types of refrigerants and their properties. Be familiar with the refrigeration cycle and its components. Know how to charge and recover refrigerants safely. Be able to troubleshoot and repair refrigeration systems. With air conditioning, understand different types of air conditioning systems and their components. Be familiar with the principles of air distribution and ventilation. Know how to calculate cooling loads for buildings. Be able to troubleshoot and repair air conditioning systems. For heating, understand different types of heating systems and their components. Be familiar with the principles of combustion and heat transfer. Know how to calculate heating loads for buildings. Be able to troubleshoot and repair heating systems. Consider energy efficiency. Understand different strategies for improving energy efficiency in HVACR systems. Be familiar with energy codes and standards. Know how to perform energy audits and identify energy-saving opportunities. Understand relevant codes and standards. Be familiar with the National Electrical Code, NEC, and other relevant codes and standards. Know how to apply these codes and standards to HVACR installations. Be able to interpret code requirements and ensure compliance. For safety, understand the importance of safety in HVACR work. Be familiar with safety procedures and precautions. Know how to use personal protective equipment, PPE. Be able to identify and mitigate potential hazards. Now let's discuss more specific concepts. Firstly, focus on understanding electrical components such as capacitors and relays. Capacitors store electrical energy and are used in HVAC systems to improve motor starting torque and power factor. Relays are electromechanical switches used to control electrical circuits in response to changes in voltage, current, or temperature. Learn how to test capacitors for proper capacitance and leakage using a multimeter. Understand the different types of relays, such as normally open and normally closed relays, and how they are used in control circuits. Secondly, explore HVACR control systems. Control systems are essential for maintaining desired temperature, humidity, and air quality levels in buildings. Learn about different types of control systems such as pneumatic, electric, and electronic control systems. Understand the function of thermostats, humidistats, and pressure sensors in control systems. Study how to troubleshoot and calibrate control systems to ensure optimal performance. Thirdly, review refrigerant handling procedures. Proper refrigerant handling is crucial for environmental protection and safety. Learn about the different types of refrigerants and their properties, such as ozone depletion potential, UP, and global warming potential, GWP. Understand the regulations and procedures for refrigerant recovery, recycling, and reclamation. Study how to use refrigerant leak detectors to identify and repair leaks in HVAC systems. Fourthly, consider air distribution systems. Efficient air distribution is essential for maintaining comfort and energy efficiency in buildings. Learn about different types of ductwork, such as rectangular, round, and flexible ductwork. Understand the principles of airflow and pressure drop in duct systems. Study how to balance air distribution systems to ensure proper airflow to each zone. Fifthly, delve into psychrometrics. Psychrometrics is the study of the thermodynamic properties of moist air. Learn how to use a psychrometric chart to determine the properties of air such as dry bulb temperature, wet bulb temperature, humidity ratio, and enthalpy. Understand how psychrometrics is used in HVACR system design and analysis. Sixthly, explore heating and cooling load calculations. Accurate load calculations are essential for selecting the appropriate size of HVACR equipment. Learn about the different factors that affect heating and cooling loads, such as building materials, insulation levels, and occupancy patterns. Understand how to use load calculation software or manual methods to estimate heating and cooling loads. Seventhly, review energy efficiency strategies. Improving energy efficiency is crucial for reducing operating costs and environmental impact. Learn about different energy efficiency strategies, such as using high-efficiency equipment, optimizing control systems, and improving building insulation. Understand how to perform energy audits to identify energy-saving opportunities. Eighthly, study the National Electrical Code, NEC. The NEC contains the standards for safe electrical installations in buildings. Learn about the relevant articles and sections of the NEC that apply to HVACR systems. Understand the requirements for wiring, grounding, and overcurrent protection. Review troubleshooting techniques. Effective troubleshooting is essential for quickly identifying and resolving problems in HVACR systems. Learn how to use diagnostic tools, such as multimeters, pressure gauges, and refrigerant leak detectors. Understand how to interpret system readings and identify the root cause of problems. Practice troubleshooting common HVACR system problems, such as compressor failures, refrigerant leaks, and electrical faults. Study about new technologies. Stay up to date on the latest advancements in HVACR technology. Learn about new equipment, controls, and refrigerants. Understand the potential benefits and challenges of new technologies. Finally, focus on sustainable practices. Sustainable practices are becoming increasingly important in the HVACR industry. Learn about green building design and construction principles. Understand the importance of using sustainable materials and refrigerants. Study how to design and install energy-efficient HVACR systems. Make sure you thoroughly cover these topics. Firstly, understand the different types of HVACR systems. This includes central air conditioning systems, heat pumps, furnaces, boilers, and ventilation systems. Learn about the components of each system and how they work together. Secondly, focus on electrical theory. This includes Ohm's law, Kirchhoff's laws, and AC and DC circuits. You should be able to calculate voltage, current, resistance, and power in electrical circuits. Thirdly, study about control systems. This includes thermostats, pressure switches, relays, and other control devices. You should be able to troubleshoot and repair control systems. Fourthly, review the refrigeration cycle. This includes the evaporator, compressor, condenser, and expansion valve. You should understand how each component works and how they interact with each other. Fifthly, study refrigerants. This includes the different types of refrigerants, their properties, and their environmental impact. You should be able to handle refrigerants safely and properly. Sixthly, review air distribution. This includes ductwork, dampers, and diffusers. You should understand how to design and balance air distribution systems. Seventhly, study about ventilation. This includes natural ventilation, mechanical ventilation, and exhaust ventilation. You should understand the importance of ventilation for indoor air quality. Eighthly, delve into energy efficiency. This includes insulation, windows, and doors. You should understand how to improve the energy efficiency of buildings. Review safety practices. This includes electrical safety, refrigerant safety, and tool safety. You should always follow safe work practices. Familiarize yourself with codes and standards. This includes the National Electrical Code, NEC, the International Mechanical Code, VIMC, and other relevant codes and standards. You should be able to interpret and apply these codes and standards, and study troubleshooting techniques. This includes using diagnostic tools and equipment to identify and resolve problems. With dedication and focused effort, success is achievable.